Hello, hi. So this is tutorial number 9D if I'm not mistaken. Okay, so kita ada helium ion of charge 2e and a mass, given the mass of the helium ion accelerated through the voltage of 2400 volt. The accelerated ion then move into a perpendicular uniform magnetic field of magnitude 0.24 Tesla. Means that you punya charge passes through electric field and also passes through magnetic field. Okay, so we're going to determine the radius of circular path of the helium ion. So saya keluarkan all the information given. I have the charge Q equal to E. So E is the electron charge lah. Okay, then I have a mass of the charge and also potential difference. Then kita ada magnetic field. Okay. For the first part of the question, we need to find the radius of the circular path of the helium, which is when it passes through the magnetic field. So what we're going to do is just draw the diagram so that you can imagine. So basically the first part, your charge going to pass through the electric field sebab dia ada potential difference. Then going to pass the magnetic field. So for example, what I did is magnetic field is into the page. So this is my assumption lah. Okay. So basically after it goes down to electric field, apa jadi dekat electric field tu adalah your charge gonna accelerate. Okay. So the velocity dekat situ. Then baru dia masuk dekat magnetic field, dia akan under circular motion. So dalam in electric field, what is happening is there's a conservation of energy there. Means that when we put the charge in there will be potential energy. Then those potential energy will be converted into kinetic energy. Okay, so potential energy is from chapter 1. So the equation for potential energy is QV. Okay, so Q will be the charge, V will be potential difference equal to half mv squared. So velocity, we arrange everything equal to set 2 QV over m. So you got to know that there's a difference between small v and capital V. Then I put all the values in there. So set, okay, so 2 Q, the charge is 2E, so 2 times 1.6 10 negative 19. Okay, then Q dekat situ dah. Okay, so potential difference is 2400 over 6.6 10 negative 27. Setkan everything. Okay, then you're going to get the answer is 4.82 10 to the power 5 meter per second. So basically, once it's done, they have the velocity that. Then you're going to enter the magnetic field. So, bila enter magnetic field, kita akan guna FB equal to FC, which is the application for chapter 6 circular motion in SP025. So dia akan buat circular path over there. So kalau kita tengok dekat situ, velocity ke kanan. Bila dia masuk enters magnetic field into the page, the FB will be upwards. So going to undergo circular motion. So FB equal to FC. So FB kita akan guna formula yang kita tulis dekat part previous parts, QVB sin theta. So theta will be 90 degree. Kenapa? Because theta is the angle between velocity dan magnetic field. So dia adalah 90 darjah. Velocity ke kanan, magnetic field is into the page in the z component, so it's 90 degree. Then we sub all the values. So Q is 2E. Okay, 2 times 1.6 10 negative 19 times 4.82 10 to the power 5. B is 0.24. Then the mass, the velocity that we got from the first part. Okay, so then kita squarekan tu over radius. So we're going to get the radius is equal to 4.14 10 to the power of negative 2 meter per meter. Okay, so for second part, the period of revolutions of the helium. Okay, so period equal to pi r over v. So 2 pi r, radius that we got before 4.14 centimeter over the velocity. So sebenarnya -7 second. Okey, itu saja.